going to look at multiplication properties of exponents. The first property we're going to look at is when we're multiplying the same variable. So for instance, in this example, we have b as our base, and then what we're going to do is we're going to add the exponents. So when multiplying, we're going to add the exponents. So for instance, x to the second times x to the third, we add the exponents and we get x to the fifth. And the reason that is because my x to the second, if I were to write them out, I'd have 2. X to the third is x times x times x, there'd be 3. And if you add all of those together, you have 5 x's. All right, let's try some examples. So the first thing we're going to do in letter A is we're going to multiply the numbers. That stays the same. 3 times 4 gives me 12. And then n to the 4th times n to the 7th, when I add those, I get 11. The next example, I have 2 times 7, which gives me 14. Now this x is x to the first. We don't write the 1, but if that helps you to write that so you can count them correctly, that's fine. So we have 1 plus 4 gives me 5. So I have 14x to the 5th. And if I look at my y's, I have y to the 5th. So 14x to the 5th, y to the 5th. Now in looking at our next property, we're going to do a power to a power. So I have a variable raised to a power. In this case, it's b to the second. And I raise that to the other power. And then I'm going to multiply those. So a power to a power, we're going to multiply. So for instance, here, I have x to the second raised to the third. I multiply 2 times 3 and I get 6. And the reason is when I have x to the second, it's saying I have it 3 times. So I have it 1, 2, 3. And at that point, I would add those. So that's just kind of a shortcut. All right. So in letter A, I have n. And then I have 5 times 3 gives me 15. In letter B, I have x. 4 times 2 gives me 8. And that's it. Now with the next property, we have a power of a product. So we have a lot of different variables and we have a coefficient in there is raised to the power. So everything inside the parentheses gets raised to that power. So for instance, 2 gets raised to that third power, so does x to the third, so does y to the second. So in this case, 2 to the third would be 8. We're multiplying x to the third times 3 gives me x to the ninth, and y to the second raised to the third also gives me y to the sixth. Okay, so let's take a look. So we have 3 to the 5th, x. Now again, remember we're multiplying. 5 times 5 gives me 25. And then we have y to the 10th. So the only thing we have to simplify at this point is 3 to the 5th. You can just use your calculator for that. So I have 243, x to the 25th, y to the 10th. Let's take a look at the next one. Now this one, -5, we have to make sure we put that in parentheses to the second if you're going to use your calculator. And then I have a, remember that's a to the first. So 1 times 2 gives me 2, and then b to the 8th. Again, the only thing I need to clean up is that -5 squared, which is positive 25, a to the second, b to the 8th. Okay, and looking at our last one, it's a little tricky. We have lots of powers going on here. So I think the easiest thing is just to take our 2 powers and let's multiply them, right? Power to a power, we multiply. So 3 times 2 gives me 6. So I'm going to take 2x, y to the third, what's inside the parentheses, and I'm going to raise that to the 6th power. So that gives me 2 to the 6th, x, remember that's the first, x to the 6th, and y to the 18th. 2 to the 6th is 64, so my final answer is 64x to the 6th, y to the 18th. All right, let's take a look at a word problem here. Shipping box is in the size of a cube, in the shape of a cube. So a cube, remember, a cube is like a dice that you would play a game with. So all sides are the same. They're the same length. What is the volume of the shipping box? So remember, volume is length times width times height. Because we know the sides are the same, there's actually 2 different ways we can do this one. We can either take the side and raise it to the third power because we're multiplying it 3 times, or this is just multiplying everything out. One side, that's my length, that's my width, that's my height. So my shortcut here would be 4 to the third, m to the 8 times 3 gives me 24, n to the 4 times third gives me 12, and again, 4 to the third is 64. That's the only thing we need to simplify. So I have 64 m to the 24th, n to the 12th. Now, if I did it the longer way, I would just multiply this 4. 4 times 4 times 4 gives me 64. And then I have 8 plus 8 plus 8 gives me m to the 24th. Same thing with the ends. Because I'm multiplying, I'm going to add them. 4 plus 4 gives me 8 plus another 4 gives me 12. So you can see the answers are the same. Now, looking at our last sets of problems, these directions say what value of n makes each statement true. So let's see what we have. First, we have to find where the n is. So I have n is right here with the x. So if I have x to the n times x to the 5th, right? I can just ignore the numbers. That equals, again, x to the 8th. So I know when multiplying, I'm going to add the exponent. So I know n has to be 3 because 3 plus 5 gives me 8. Looking at number 2, remember this is a power to a power. So when I multiply, that's what I get. Right? That's what I have on the right-hand side. So 2n is equal to 12. If you can't do that in your head, then just go through the process and do what you have to do to get n by itself. So in this case, n is equal to 6. In number 3, my n is my coefficient, my number. So I'm not going to worry about my x's or my y's. I'm just going to worry about my number there, my coefficient. So that gives me 6 to the 3rd is equal to n. 6 to the 3rd is 216. Okay, and our last one, our n is our power. So we could either use the number or x's or y's, doesn't matter. We just need to do one. I'm going to use y just because it's the closest. So I know y, and then power to a power, I'm going to multiply. And I know that is equal to y to the 25th. So again, if you can't see that right away in your head, we can just kind of pull that out, and n is equal to 5. Okay, thanks so much for stopping by today. Have a great day.